Okay, in this video we're going to be looking at slope fields. Okay, so a couple things to keep in mind and remember from what we did previously. Remember that let f, capital F of x be an antiderivative of f of x, small f. Then f, capital F prime equals f of x. And then we know then that if I find that this means the antiderivative of this gives me this function right here, which is a family of functions. This produces a family of functions that differ only by a constant. If we graph these functions, we would get something that looks like this graph over here. Okay, of course there would be an infinite number of them because every constant would produce another graph, and you can see how they are stacked one on top of each other, kind of nest everything out. So what we're going to be doing now we are given an equation for the derivative f of x. We can then discern information about this function. Okay, can I discern information? And that's where slope fields comes in. A slope field is a visual representation of the solution set to a differential equation, where y prime equals f of x or y, whether we can find the general antiderivative or not. So if I can't find the antiderivative of a function, I can do what's called a slope field and kind of get kind of like a visual, and you'll see how that works here in just a moment. Remember, the derivative dy dx can be thought of as the slope of a tangent line at a specific coordinate xy. So I can draw a little tangent line right here, is what we're looking at for a slope field. You're drawing little tiny slope segments. When we sketch a slope field, which is what we're going to do here in just a moment, here are some criteria we need to follow. If we pick a point that we're going to put a dot at, a segment at, if the derivative there is 0, then we're going to put a little tiny horizontal line segment at that point. If it's positive, we're going to put a positive slope segment, negative slope segment. Okay, and if it's undefined, we're not going to put anything. Okay, you could put a vertical line segment, but it's better to just leave it blank. Okay, don't put anything there because it's really not defined. Your derivative is not defined. You shouldn't have anything there. Okay, and for the positive and negative slopes, you're going to estimate the angle to match the value. So if I have a slope here, for example, that's positive 1, I'm going to try and draw a segment that has a slope of 1. If I have one that has a slope of 5, I want it to be much steeper than the one that has a slope of 1. And I'll show you some techniques for that here in just a moment. So that's what we're going to do, and we're going to draw some of our sketches out, and I'll walk you through this process. I have quite a lot of examples, but I may not do them all, just to see how things work out here. So this is typical what you might see, a little coordinate system with some dots on it. Okay, and your goal is to sketch the slope field at each one of these dots. Okay, and so what you're doing here is you're going to just simply plug in values at these dots in here and find out what the derivative is at that point. So you can make a table, which is probably highly recommended. You can have an x, a y, and a dy dx value. Okay, so what point am I going to use? Well, start on the ones that are, have zeros for either x or y, things like that. You'll notice that it's all blank here at the y equals 0 value. All of these x-intercepts have a y value of 0, so you cannot have 0 in the bottom, so they are all blank. Okay? So we can pick another one, and just do the numbers on the next axis. So we have 1, 2, negative 1, negative 2, and the x's are all 0. So if I do those points, this point right here is going to be 0, 1, then I have 0, 2, 0, negative 1, 0, negative 2, and you can see that there's going to be, in this particular case, they're all going to be 0. These are all zeros. So when I come over here and draw it, I'm going to draw a little tiny horizontal segment at each of these points, just like that, as best you can. This is how you draw a slope field. Little segment, all horizontal, right there. And so the next thing you're going to do is you're going to just start plugging points in and seeing what you get. Okay, you can start paying attention to what you might get before you plug a point in. But let's just go ahead and take a look. This is the point 1, 1. If I plug in 1, 1, then I'm going to get a negative 1 over 1, which is negative 1. So this point has a negative 1 slope. So here's how I do it. If you can, slope of 1, negative 1 is down 1 over 1. So just kind of visualize the line segment here, just like that, and then draw the segment just like that. Negative 1. Kind of aim for the next dot right there. Okay? So if I'm from here and I'm aiming here, then I can just draw that segment. And don't draw it too big. And you just rinse and repeat this process until you get all of these dots filled in. Okay? If I do this one over here, this is going to be the point 2 on the x, 1 on the y, and so I'm going to get negative 2. Okay? So then I got to draw a negative 2 here. Okay? Well, I can't see the next 2 points up. But I know this is 1 point up and the next point's right there. Okay? So I know that I need to get up to that point. Okay? Up 2 over 1. I need to aim for that point right there, which is going to be halfway in between these 2 points. So literally I'm going to go for halfway between those 2 points, and that gives me a slope of negative 2, kind of like that. And you can do that same process for some of these other things. Let me go ahead and show you this one over here. Now x is 1, y is 2, so I'm going to get a negative 1/2. So this one has a negative 1/2. Well, what does that mean? Okay, well, it means down 1 and over 2. Okay, is where I need to go. And so where is that going to land? Well, it's going to land halfway between these 2 dots. If I connect it out to here, it's going to be halfway between those 2 dots. And so that's what I aim for. And it kind of gives me a little less steep slope than that. And then the last one right here is 2, 2. So 2, 2, and then you see we're going to get negative 1 again. All right, so that's kind of interesting. So negative 1 again. That was a negative 1, and that was a negative 1. So is that a pattern? Is this pattern always going to be this way? Would it continue on through? These are the kind of questions you ask yourself. What is the pattern of approaching on these things? And in fact, it kind of does. These are all going to be negatives. In this quadrant over here where x is negative and y is positive, this will turn positive. So all the slopes in here are going to be positive. Down here, x is negative, y is negative, and that's negative. So my answers in here will all be negatives. And this one over here will all be positives. Okay, for the same reason those are. And so these things are all negative 1s. These things will be negative 1 also. Just in this particular case. Because negative 1, negative 1, negative 1, negative 1, negative is positive 1. At negative 1, negative 1, we have a positive 1 now. I'm sorry, negative, because there's 3 negatives. Negative 1 again. So the same thing applies in this one. And then this one will be the same. And these are all going to mirror image each other. Okay, so that's what's going to happen here. So this is x is negative 2, y is negative 1. This is going to give me a negative 2. This is the negative 2. That was the negative 2. See the symmetry? Okay, and so we're aiming for this one. And then this one over here is going to be the 1/2. So we aim that one. And then these things are going to be just the positive version of those things. 1, negative 1, positive 1. This will be a positive 1. See, I don't have to do all of them that way, where I got to plug them all in, because I can see trends, and that's what I'm shooting for. This one's going to be the same as that one, just going to be on the positive side of things. So, just like that. And this one's going to be like that one, just the positive of things. Just like that. And same thing over here. This one's going to be the 2. And this one's going to be the 1/2. Oops, went the wrong way. And if you look at back up a little bit, you can see that, oh, that's an interesting little pattern here, isn't it? Almost like a circular action going on here, but we do have an undefined here, so we can't cross it. So interesting things, I can look at this and see kind of patterns in the overall solution graph. Okay, so I'm not going to draw this one because you can see there's a lot more points, but I will show you what this looks like after you have finished drawing it. So let me go ahead and show you that, and I'll show you what I did for the other one, and then I'll show you some more processes that you may follow. So here is the one we just did, okay, and some trends we noticed. So if you need to pause and write that down, you can. And here's the other one that I'm not going to draw that was a lot more points. The same thing again, we do the same process. You just take your time and go through it. What do I notice about things? Okay. Look for where dy dx is 0, so that's where I usually will start. And you'll notice that this diagonal are all 0. And then this diagonal, they're all the same value. Okay. And what's happening on the other side, what's happening on this side. And as you go through this, you'll start seeing the bigger picture here again. If I can do more dots, I can see a better picture. Okay. So let's look at another example of this, where I can see more line segments. So now I have this one, and I've drawn a bigger slope field. And part of the question types you'll be asked to do, these are the two types you'll be asked to do the most. The first one is draw a slope field, what we just showed you. And the second one is, here's a slope field, which one of these do you think represents it? And so when you do this, they gave you the differential equations. This is a slope field of differential for the differential slope here. And so just look for what you see in here, any kind of patterns. Find out where things are positive, find out where things are negative, look for things that might be 0 or undefined, okay? And then use that to your advantage. Look at your stuff over here. There's nothing on the y-axis, okay? Does that mean it's undefined there? I don't know. It could just not be have a mark there. All right, none of these are necessarily on line. There's no marks here at -2 or slightly off, so everything's kind of slightly off. But look for areas where we have 0 slopes, look for where we have undefined slopes, look for where we have positive or negative. Now, is there anything that we see in these problems? And so you look over here, and in quadrant 1, it looks like all of my slopes are negative. See that? So all the points up in here are x and y are both positive, but all the slopes are negative. Okay? So we can come over here and say, okay, if I plug in a positive and a positive, I need to get a negative. Well, that one's out. There's no way that's going to happen here. Positive plus a positive and get a negative. A is now out. In quadrant 3, all the slopes are positive. So if I plug in an x and a y, I need to get a positive answer. Is it possible for that to occur? Okay. Can I plug in a negative number here and a negative number here and get positive? Well, I can for some, but not for all. If I plug in a small x that's negative and a y, like a -5 for y and a -1 for x, I'll get positive. But what if I switch that around? Is that going to happen? You know, if I pick x is -5 and y is -1, do I get a positive slope? Well, it'll be a -5. It'll be a -5 minus a -1. Well, that's going to be a -4, so that's not true. So I think B is out. And likewise, because these are just reverse of each other, D is out. So there's really only one choice left, and that's C, but we should confirm it. If I plug in a negative and a negative for x and y, then that just turns everything positive, those two minus signs there. If I plug in a negative and negative, positive and positive gives me negative answers. If I plug in two negatives, into these things, then everything turns positive. Good. And then you can look at these things and see what's happening over here and can confirm that this indeed is C, the correct answer. So C is the correct answer in this problem. But that's the kind of things you're going to be asked to do on that sense. Here's another one of the same type. You just kind of take a look at it. Here's another one. We want to try and find it. And you'll notice here that where is it 0? Where is it undefined? Where is it positive? Where is it negative? And you'll see a couple things in here that's interesting. All of these on the x-axis are 0. And all of them at -1 are 0. Okay? So what can I do in this situation? How should I look at this stuff? Well, look at my answer choices over here, and I'll notice that some of these things can maybe be factored. So if I factor out a common factor for these and get it as a product, I might be able to see this a little bit more clearly. In fact, if I do B, I take out the y, I'll get x minus 1. This is for B. If I take C, I'll get y times x plus 1. And if I take, you can't see what I'm doing here, if I take D, and I'll get x times y plus 1. Okay, if I take those. So if I look at those, and this one's already a product, so when y is 0, that would be 0. When y is 0, that's 0. When y is 0, that's 0. When y is 0, well, that's not. Okay, so I think D is out. When x is -1, I need to get a 0, so that's out. When x is -1, that would be out because that would be -2. If x is -1, that's 0. See? And so already we have found the correct answer, C. C is the correct answer for this problem. And that's how you can kind of find those things fairly quickly. All right? Let's look at some other kinds of questions that you might see. So in this particular case, here's the differential equation right here. Here's the slope field from that. I've drawn it for you. Okay. While the slope field to the right is drawn for several points, it is defined for every point in the xy plane. Describe all the points in the xy plane for which the slopes are positive. This is another kind of question that they would ask you to do. Describe what the slope field is doing. And so you can look at the slope field for some trends, but you need to look at it for beyond that. Okay? The question is I want to describe the points in the xy plane for which the slopes are positive. This is a formula for the slopes, so I need to know when is dy dx, which is this thing right here, x squared times y minus 1, when is that greater than 0? That's my question. Okay? So to be greater than 0, what has to be true? Well, for the x portion of this, x just can't be 0. X cannot be 0 because then it would be equal to 0. Now, if x was a negative value and I square it, I'm going to get positive. If x is a positive value and I square it, I'm going to get positive. So that's the only stipulation on the x that I need to worry about. What does y have to be greater than 0? Well, it can't be equal to 1 because that would be 0. And it can't be less than 1 because then it turns into a negative value. So that means y has to be greater than 1. So then your description here, describe all the points in the xy plane for which the slopes are positive. You simply write all the points in the xy plane where x does not equal 0 and y is greater than 1 will have positive slopes. And so that's how they would do that one. Okay, let's look at the next one down here. I'm going to let you guys work that one out. I'm going to pause it here and then I'll show you the solution that I got for it. So consider this differential equation right here. Here's the slope field for it for several points. It is also defined for every point in the xy plane except for when y equals 0 because you got a y on the bottom. So y cannot equal 0. Describe all the points in the xy plane for where y is not equal to 0, for which the derivative is -1. Okay, so take a moment here, pause this out, see if you can figure that out, and then I'll come back here in just a moment and see what you guys came up with. Okay, so if you paused it, we can take a look at some stuff here, and we're back to this. And so take a look, and you can see right here that we have a trend right here, which is simply saying these are all going to be 0. Okay, and that makes sense right there, correct? All right, just looking at some numbers here, getting a feel for it. But I want to know for when the derivative is equal to -1, well, that's the derivative equation. So when is dy dx, which is equal to x plus 1 over y equal -1. We need to solve that equation right there. So using our techniques for solving this, we get x plus 1 equals a -y. So y is a -x minus 1. So where is in the xy plane dy dx equal to -1? For y equals to -x minus 1 and y not equal to 0. That is when it's going to happen in those scenarios there. I can't tell if that's in your way or not. So that's what I have down for this. And that's what you're going to be asked to do. Describe slope field scenarios. Okay? Let's take a look at some other questions that might come up. Another use of slope fields is to be able to identify patterns in the slopes and be able to draw a possible solution to the differential equation. Okay? So we're going to take a look at this one and see how this looks and how I might do something like this. This is another question you will see on the AP exam and also on your test. So I got several of these. Again, I won't do them all. I'll just give you an idea of how to go about doing this. Okay? So the first thing here is, here's a differential equation, 1/2 x times y plus 2. A slope field for the differential equation is shown over here. Sketch a solution curve that passes through 2, -2, and then sketch another solution curve that passes through that. Remember, these are nested solution curves. Remember, like the very beginning, it had one on top of the other, so there's going to be one that goes to that point and one that goes to that point. Okay? Now, the thing to keep in mind here is that these are little tangent lines to a curve. These are not things on the curve. Okay? The curve is between the lines, let's put it that way. All right? Don't go through the lines. You're going to go between them. Think of this as a trend of what the lines are doing, okay? They don't have to be perfect, okay? But it needs to, you're going to go between the lines, don't go through them, go between them, through the gaps, look at the trend that's happening and things like that. What's going on if I follow this thing out? Okay? Different locations can give different looks also. You can go through and kind of follow what's going on. So if I need to go through this point right here, look at where it's at. Look at all the up and below it. See how these things are kind of like forcing the dot to go this way, right? Or if I'm over here, it's forcing me to go that way. So what I have right here is actually have a line. A solution would be this line right here. Right through that point. And think about it. Why? Why would it be horizontal? Okay, take a look. What happens when y is -2? Okay? That's the slope field, right? So the slopes here are that. So the solution curve is going to be this, making me go in that direction. This one's a little bit different. Okay? If I'm going to go through this one, what's going on? If I'm coming up here, coming through here, see how it's getting really steep? So it's going to be really steep, and it's going to go through here, right? And then as I get here, it gets less steep. And then it has to turn horizontal. You see that? And then it goes back to steep again. So we got a curvature that goes like that. That is the solution, just like that. See what my pen is doing? And so that's what you need to draw as best you can through these things. Don't worry too much about stuff. Just go through here, go through the dots, come around, And you could have come back up. I missed it a little bit. We'll come over here. But that's the idea that's going on. Okay? That's the idea. That's kind of like a solution curve. It's not pretty. It's not perfect. Okay? If I could redraw it, I probably would. Looking at it from now, it's like it looks a little off. Okay? So I can erase it. So do it in pencil first. I started well, and then I got a little carried away. I think it's a little flatter on the end. Maybe coming down like that. Coming through here and down below. Horizontal. And then come around and kind of do the same thing. Come out this way. Like so. That looks a little bit better to me. And so that's what I'm going to go with. And that's a solution curve. Okay? You can do one down here for this. Sketch a graph that goes through here. See, this is more of a up and down motion. So think about what function kind of maybe does that. Okay? And see if we can't draw that. And so we can come across here. And it comes up like this. And then it has to come back down. And we're going through the curves, correct? Through the slopes. It doesn't want to go down. See how these things are turning? It doesn't want to go down here. It wants me to turn back up. See, the slopes go in between. See it? Like you're flowing. There it is. Slope solution. Okay? And you can try and find a solution to that if you needed to. You can figure out which kind of function this might look like. It's an M. You should already be thinking that it's a cosine in some fashion. W's and M's look like cosines. And that's kind of what's going on there. All right? I have other pictures that we can look at. Here's another one. See how we have little almost going out. See how it's turning flat as you go out? Little hump and flat as you go out. So you can kind of see what that graph is going to look like, just like that, right? And you can draw a solution curve to this. Looks like it's coming around like this and then going out flat. Coming around this way and going out flat. Oops. And you go down to the coming out this way and going out flat. So which one of those could be a solution? See how it's different now? Now I'm looking for the solution. This is what I drew. This is the difference between this question and the one before. Okay? Here we were trying to draw it in here, but now I'm going one step farther. So there's the graph. Here's the graph. Here's the slope field, and then we drew the solution curve. So which one of these do you think it could be? So now I need to identify that curve. This is another question type that you'll have, where you have to identify it. So that's why we draw it, okay? And then we look down here and say, well, which one of these does this look like? Well, you can start doing a process of elimination here. It doesn't look like this one. That's a square root graph. I mean, it might, who knows? It's not that one, definitely not that one. It's definitely not that one, okay? This is a polynomial. It shouldn't go flat on the edge. It doesn't have a horizontal asymptote. Okay? And so we look at these things and say, well, which one could it possibly be? And the one that most closely resembles it would be this one right here. So E is our correct answer for this one. And here's another example of the same type of problem again. So here's my slope field. Which one of these equations could it possibly be a solution to this differential slope field? Notice this time I did not give you, in these two cases, I did not give you the differential equation that maps the slope field. So here's the slope field. Which one of these could be a solution? Okay? And so you look at this and what's going on? Well, it looks like I have a vertical asymptote at 0. It looks like the graphs are coming up and over like this. So which graph down over here looks like this kind of a function? And I hope everybody recognizes very quickly that if I drew one in here, it would look something like that. And that graph looks like a natural log. Okay? So that's how slope fields work. And those are the different looks you're going to have for slope field. You're going to be asked all these different kinds of questions on the AP exam and on your test itself. Given a slope field, try and find a solution. Try and draw a particular solution through a slope field, identifying the function itself. I didn't have any extra notes here for that one. I did have some extra notes for this one, so if you want to take a look at that and write that down. But the same thing. Here's a slope field, gave you the differential equation. Try and draw a solution curve through certain points. This is a classic kind of a problem you will see. Most likely will be a test question. Another thing about drawing your slope field solutions, your graph needs to go from edge to edge. Don't cut it short. Don't stop it halfway. Don't stop over here. Go all the way through, all the way through, all the way through. So when you do that, because if you don't, they're going to mark you off. Okay? So anytime you need something, just pause and write it out. Okay? Can't remember if I showed you stuff or not, but we have all of that. And I think we're good to go. So that will end this video right here for slope fields, and we'll do more problems and examples together.